Okay, so now let's talk about some of the specific characteristics of steel. And you can see I've grouped these characteristics into advantages and disadvantages. And I'm going to hop back and forth between the two as we go down the page. So, starting with our first advantage. Structural steel has a very high strength to weight ratio. This by no means implies that steel is a light material. In fact, it is incredibly dense and very heavy, but for its weight, it is very, very strong. So you can see here that steel has a density of about 500 pounds per cubic foot. So every 1 foot by 1 foot by 1 foot cube of steel is going to weigh roughly 500 pounds. However, as we've seen in previous weeks, steel also has a yield strength of around 50 kips per square inch, and that's using grade A992 steel. There are also even higher grades of steel, and they're becoming more and more readily available. But for right now, most steel shapes, including our typical wide flange, will have a yield strength of 50 kips per square inch. And so, if we have a 1 foot by 1 foot by 1 foot cube of steel that is A992 50 kips per square inch yield strength steel, that block, as I said before, will weigh 490 pounds, and its strength, if we applied a tension force to it and tried to pull that cube apart, it would only start to yield if we could apply greater than 7,200,000 pounds. So, even though this block is very heavy, it has an unbelievable amount of strength to it. And so that allows us to create these very slim shapes, like the wide flange section, that have very high capacities, but only using a small amount of material. And so, due to its high strength to weight ratio, steel is optimal for long span construction. And so that's why you'll often see steel incorporated into a lot of bridges or sports arenas. Also, having this high strength to weight ratio material means that the building will be lighter, which means there will be less impact on the foundations and less shipping cost, both monetary cost and environmental cost. Now, jumping over to a disadvantage, steel has very low fire resistivity. In fact, it starts to degrade very quickly under high temperatures, meaning that you will not be getting this 50 kip per square inch yield strength under high temperatures, and the steel will start to warp. And so in most buildings we will need to protect the steel in some way, and there are a variety of different methods for protecting steel from high temperatures. The first would be intumescent paint. Intumescent paint looks like any normal paint, but when subjected to high temperatures, its thickness will expand to about 100 times, creating a barrier between the structural material and the high temperatures. Intumescent paint is, however, very expensive, and so it's typically only reserved for architecturally exposed structural steel, where you need a nice clean look. For areas where aesthetic is less of a concern, we have spray-applied fire-resistive material, which is typically some type of low-density material or some cementitious mix that is applied to the structural members. And it gives the members this kind of fuzzy look to it. You'll see this a lot in parking garages or occasionally some open office floor plan type buildings, like we have at Canon. And finally, the last method for protecting structural steel from high temperatures is encasement. And this encasement can either be some type of gypsum board like is shown here, or encasing the column in concrete. Now, jumping over to another advantage, structural steel tends to have a very, very fast construction schedule. All of the structural members can be fabricated somewhere off-site, and occasionally this fabrication process can even overlap with parts of the design process of the project. And so as soon as the construction documents are turned over to the construction manager, those prefabricated pieces of steel can be brought to the site very quickly and start to go up almost immediately. And of course, with a lot of these buildings, time is very much so equal to money. The sooner the owner can get occupants inside the building, the sooner they can start to see a return on their investment. And so in cases where owners are concerned about having a fast schedule, typically steel is the way to go. Now, back to the negative side of things. Steel has very low environmental resistivity. And when exposed to water, steel will rust. And so in any type of outdoor application, steel needs to be protected from the elements. And typically the way that we protect steel from the elements in outdoor applications is through a process called galvanizing. Galvanizing is a process where we take a structural element and dip it into a bath of very hot molten zinc. And when we dip the steel element into the zinc bath, there is a metallurgical reaction that occurs in the member, and a barrier is formed around the steel. This process of hot dip galvanizing can increase the lifespan of the steel to 75 years or more. However, there are limitations to the size of the members that can be dipped into these baths. And of course, there is cost that is added to the project by introducing this process. On the lower budget end of protecting steel from the elements, we also have galvanizing paint. And this galvanizing paint is applied to elements by hand. And unlike hot dip galvanizing, there's not a chemical or metallurgical reaction that takes place. And so it's simply a coating that's formed around the steel element. And like any other kind of paint, galvanizing paint can be chipped or scratched away, and so there is more maintenance that's required, and the lifespan of the steel will not be anywhere close to 75 years. Back to the advantages side, I'm actually going to group these next two together. We have availability and consistency. Here in the United States, we have a lot of steel mills all across the country, and so steel tends to be a very readily available material for most projects. Also, because steel elements are prefabricated in these steel mills under very highly controlled conditions, it's very easy to get a very consistent product. As I said before, there are different grades for different types of steel, and these grades will be specified in the construction documents and in the specifications for the project. And it's generally very easy for the steel mill to be able to follow these guidelines to be able to meet the grade, and the structural engineer can have confidence that what they specify is what they're getting or better. Now, on the negative side of things, because steel has a high strength to weight ratio, and because we can design buildings to be very light using steel, steel buildings also tend to be more prone to vibration issues than other types of materials, simply because there isn't as much mass to be able to absorb the vibrations. And if you've ever worked in a steel office building, you will definitely know what I'm talking about. On the advantages side, steel is a very ductile material, and ductility we defined a couple weeks ago using our stress-strain curve. Steel is a very ductile material, meaning that it can undergo a large amount of strain before rupturing, unlike a brittle material which ruptures under very little strain. And so, with steel being a very ductile material, that means that steel gives more warning signs if anything happens to be wrong. So for example, if a beam happened to be overloaded for whatever reason, if the beam were made out of steel, there would be some visible deflection that an owner would be able to see, and they would be able to call in a structural engineer to investigate that member further. To finish off the disadvantages of steel, steel cannot as easily accommodate curvature in abstract forms as other types of material. And trying to design a building with lots of curvature or strange geometry out of steel can add a lot of cost to a project. That's not to say that it can't be done, however, it comes at a cost, especially when compared to other types of material. And to finish off our advantages, steel can accommodate penetrations and openings for MEP systems relatively easily. And we've already talked about how we accommodate for beam penetrations through wide flange members. And I also showed earlier how penetrations through floor slabs can be very easily accommodated through additional beams. And so that basically covers the main advantages and disadvantages of structural steel. And in the next video, we will be jumping into some common steel shapes, as well as sizing different structural elements using steel.